Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosine River College in Sacramento, California. You should have, if you're watching my video series in order, already gone through everything you need to graph sine and cosine functions. There's probably 1, 2, 3, 4, there are 5 videos prior to this that you should have gone through, or if you feel confident and you've done trig before, that's fine. However, it might be beneficial to watch those videos again, just in case. So let's talk about kind of the final frontiers, kind of the obscure styles of questions. After you're done learning how to graph, like what other things could be asked of you? A couple more things would be the case. One being that you're given graphs. And so that's what we're going to do here, given graphs, and then you need to create the function. So in this case, we're given this graph here, and we're told to write the equation for the function graphed below. Now, it turns out that you only really need a few pieces of information to get the full function for whatever trig function you're facing. If you look at that, that looks like a cosine, doesn't it? Except it's upside down. So I'm really looking at a negative some number times cosine of bx plus c plus d. That's a great way to start. Just what trig function is it first? And then determine, is it upside down, right side up, who knows? And now you go through and start labeling a couple things. Like if you have points, which we do, you can label them. This is 0, -4. X equals 0, y equals -4. And this one right here is pi over 2, 2, it looks like. And over here, this is pi, -4. There's a lot of information to be gleaned just from those 3 points. For example, the distance here is the period. That's one full cycle of the cosine. And that distance from 0 to pi, well, that's a distance of pi. It would be the right x value minus the left x value. That's critical if you're in a pre-calculus class because you're moving into calculus, and I use that notation a lot in calculus. So it's the right x value minus the left x value. That's how you compute distances, at least in the x-axis. So pi minus 0 or pi. That's our period. Also, they didn't explicitly give us a midline, did they? But I could probably guess that the midline is somewhere around here. Hard to tell. But the easiest way to figure it out is that it is halfway between these two y values. Let me state that clearly. I'll write it over here, right here. The midline is located halfway between the y values for the maximum and minimum. So basically, you can just find the average of the y values. That's all you really need to do. So the average of the y values, y average, which is actually equal to the midline, is equal to, well, we'll add those two y values together, the 2 and the -4. That's the y values at the maximum and the minimum, and we'll divide it by 2. You add them up, divide it by 2. Well, if you add them up, you get -2 over 2, and division becomes -1. And that kind of works with our logic here, right? This midline looks to be at about a -1, so that works out. Now remember what the midline gives us. It gives us D. So we have D all of a sudden. We have the period. We could totally tell there's no phase shift. It is starting at x equals 0. So there's no phase shift. I'll point out this and I'll just say no phase shift, which means that C is 0. C causes phase shifts. So because we don't have a phase shift, C is going to be 0. Let's fill in what we have so far. We currently have y is equal to, we know it's an upside down cosine curve. We don't know what the amplitude is yet. We don't know what b is. Even though I said the period is pi, that's not b. B is never equal to the period. B has something to do with the period, but it's never equal to the period itself. C is 0 because there's no phase shift, and D is our vertical shift, down 1. Okay, but the period, we've just said, is pi. But remember, the period should be 2 pi over b. So you can take this equation and solve it for b. Multiply both sides by b, divide both sides by pi, and you would get that b is equal to 2. So now our equation becomes more refined. It's a negative a cosine of 2x and then minus 1. Now we just need to know what the amplitude is. Well, remember, the amplitude is the distance between the midline and a maximum or a minimum. Let me say that again. I'll write it right here. Well, since the amplitude is that distance between the midline and the maximum or the minimum, it doesn't really matter. It's the distance between -1 and +2. Well, that's 3 units of distance. So I know the amplitude must be 3. Again, we have a maximum at 2 and our midline at -1. So it's a distance. It's what a subtraction is. And so there we go. We get 3. So thus our final function is y equals a negative, because it's upside down cosine, 3 cosine of 2x minus 1. Now, to be honest with you, a lot of people want some algorithm for doing this. And I didn't really present this algorithmically. I just went through and just kind of said, well, because of this and because of that, you do this, whatever. I didn't give you a step by step. And a lot of people prefer steps by steps. I can't really give you one here, other than to say that you should, or you could, I suppose, go in the order of lettering, A, B, C, and D. You could totally do that. Let's see how that works, actually. Let's do it with this problem, actually. So again, this time you have choices. You don't have to use cosine. You could use sine here if you want. But I will say that it is often much easier to use the cosine because the cosine starts at a minimum or a maximum, and it's just easier to see that on a graph. So I personally think that a cosine is the way to go here. So I'm going to go ahead and say this is like a cosine. Y equals some cosine A times a cosine of bx plus c plus d. And we'll go in alphabetical order here. Before we start with the A, though, let me just mention, if this is a cosine curve, excuse me, if it's a cosine curve and we're just considering it to look like this, right? That's the cosine curve we're looking at. First of all, it has been shifted. That's not our real thing that I'm talking about here. But the second thing to note really is that it's upside down. So I'm going to go ahead and write that this is equal to actually a negative amplitude cosine of bx plus c plus d. Okay. Now, let's go ahead and talk about the amplitude. Well, I'd love to know what this midline is so I could find the amplitude. And remember, the midline is the average of the y values for the maximums and minimums. So the midline right here, y equals, we can find midline is going to be, whoops, how about midline? Is going to be the average of y values, y max and min. I'm not going to write that out. I'll just do it. So it's going to be 6 plus -4. Those are the y values for the maximum and the minimum. So 6 plus -4, and we average those up. So that's going to be 2 over 2, which is 1. So it looks like our midline occurs at 1. And actually, it does kind of look like our midline occurs at a height of 1. And to find the amplitude, it's the distance between that midline and either your maximum or your minimum. They're the same distance. And we happen to know that this distance here is a distance of 5. 6 minus 1. So there we go. Amplitude is 5. So this equals a negative 5 cosine of bx plus c plus d. Well, what is b associated with? It's not exactly the period. In fact, that's so important, I'm just going to write that up above. I'll write it right here. It's not the period. It is related to the period. The period is actually 2 pi over b. So that's kind of critical to note. So how do you find that b? Well, notice that at x equals pi over 6, let me write this right here. X equals pi over 6 is where our current cycle of the cosine starts, and they didn't give us where it ends, but they did tell us halfway point. The halfway point is at pi over 2. So if that's the halfway point, you could just find the distance between pi over 2 and pi over 6 and double it. So the actual period would be the distance between pi over 2 and pi over 6, because again, pi over 6 is when we start our curve. Pi over 2, we're only halfway through. So let's go ahead and find that distance. Pi over 2 minus pi over 6, and we're going to double it. And we're doubling it because you want to get all the way here. That distance from here over to here is the period. So we want that full distance. Pi over 2 minus pi over 6 is 2 pi over 6, which is 2 pi over 6. I'll just write it that way first of all, which is a pi over 3. So this is a 2 pi over 3. That's our period, not b, but our period. Luckily, we know that the period is equal to 2 pi over b. So 2 pi over b must be the same thing as 2 pi over 3. And what does it tell us about b? Well, that it has to be 3. So let's go ahead and write that in. Negative 5 cosine of 3x plus c plus d. Okay, continuing through the alphabet. C, what is C associated with? Well, the period is associated with B. C is associated with the phase shift. And our phase shift is where we started graphing. And this graph, at least where we're considering it, got started at pi over 6. So our phase shift, which normally is a negative c over b, is equal to pi over 6. But we know what b is. B is 3. So that block implies negative c over 3 is equal to pi over 6. Multiply both sides by 3. You get negative c is equal to 3 pi over 6, which is pi over 2. And multiply both sides by negative 1. C is equal to a negative pi over 6. Oops, pi over 2. That's what I meant to say. So, if c is equal to a negative pi over 2, I can now fill that in. Here we go. Equals negative 5 cosine of 3x minus pi over 2 plus d. So far, so good. Let me box that up if I can, if it'll let me. There we go. Finally, d is just the vertical shift. How far up or down? And that one is just the midline. It's y equals 1. So we are completely done once we write plus 1 here. Equals negative 5 cosine of 3x minus pi over 2 and then plus 1. That is one function that describes this curve. There are an infinite number of answers actually that describe this curve. I should give you a fair warning. Some people might say, well, what if I took the negative sign and started right here? There's a problem with that. You do not know that that's where the sine actually starts. The fact that they gave me a minimum and a maximum, I can start a cosine curve at a minimum or a maximum. So that's generally why I look for cosine curves. If they are blatantly giving me a sine curve, then fine, I will deal with a sine curve. But often when given a graph of a trigonometric function, I will trade it out for a cosine curve because of the maximums and minimums. So that's what I think I'm going to do with this last example. It looks like, and actually I did, looks like they handed me a sine curve. While I could technically try to do a cosine curve here, the problem with trying to do a cosine curve here is they gave me a minimum, but they did not tell me where this maximum occurred. Is it at, I don't know, 3 pi plus something? I have no idea what that x value is. So I have to use the points they gave me, and this just seems to imply that the curve, the sine curve, starts right here. So I'm going to make that assumption that we have a sine curve. It just continues forever. They gave me 2 points. It's technically all I really need. So let's go ahead and say it is a sine curve. It is y equals, it's actually an upside down sine curve. Negative a sine of bx plus c plus d. And let's go in alphabetical order. I am going to make the strong assumption that this is the midline. And I say that's a strong assumption because they gave me that point. That implies it is the midline. Okay, so the midline is at y equals -2. And this tells me the amplitude actually, because the amplitude is the distance between the midline and either a minimum or a maximum. So I could either use the distance between -2 and the x-axis, which is 2, or the distance between -2 and -4, which is 2. But the amplitude in either case is 2. Let's go ahead and fill that in here. So this is going to equal a -2 sine of bx plus c and then plus d. Now let's talk about the period, because that's what b is affected by. So the period of this function. This is very similar to the last example in that they didn't actually tell us the full period of this. In fact, they don't even graph the full period of it, right? They didn't finish it out. But they gave us a little bit of this function. Remember, if it was a sine curve, half of the period would get us to here. That's half the period. But they actually gave us a quarter of the period right here. So this is 1/4 of the period. And that distance is equal to 7 pi over 6 minus pi over 6. That's what the distance between those two x values is. X right minus x left. That's a 6 pi over 6 or a pi. So the period, 1/4 of the period is pi. So the period must equal 4 pi. Now that looks to be about right. So if the period is 4 pi, remember to kind of transpose that into this function, the period is supposed to be 2 pi over b. 2 pi over b. If you solve that equation for b, multiplying both sides by b and dividing both sides by 4 pi, you'll get b is equal to 1/2. Let's go ahead and plug that in. Zooming in here to do that, equals a -2 sine of 1/2 x plus c and then plus d. Well, what is c associated with? C is associated with our phase shift, where we started graphing. And we started graphing at pi over 6. So our phase shift, I'll write right here, whoops, except I don't want to write it in highlighter. Phase shift is pi over 6. But that's supposed to be the same thing as -c over b. Well, okay, we know that b is a half, so this implies that pi over 6 must equal a -c over b, which is a half. Well, let me go ahead and clean this up. I'm going to, let's go ahead and multiply both the right-hand side of that numerator and denominator by 2, just to start there. So I think I might lose people if I do something else. So this will be a negative 2c. Then I'll divide by a negative 2. So I get negative pi over 12 is equal to c. Great, I found c, negative pi over 12. So I'll go ahead and go over here. Equals negative 2 sine of 1/2 x minus pi over 12. And then plus d. Now that we've done that, let's go ahead and find d. And d here is going to be found from our vertical shift, which is a negative 2. I'll go ahead and highlight that so you can see where I'm looking. Negative 2 right there. So that's what d is. D is kind of the easiest of the group. So our full function is, except it can't be written in highlighter, is a negative 2 sine of 1/2 x minus pi over 12 and then minus 2. Now, just to let you know, again, I mentioned it in the last problem, maybe the previous 2 problems, I can't remember, but there are an infinite number of answers to something like this. So if you compute it and you say, that's not what I got, I recommend going to Desmos and graph what you have and graph what I have. And you'll see, if you're correct, that they're the same function. Okay, that's it for this. That's just finding equations from graphs. The final video in this series is going to be applications, which is one of my favorite topics. So I'll see you there.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.